so far. Hello? Hi out there in Facebook land, welcome. I'm gonna give it a minute or two. You see behind me, here are Ender 3 printers, which are 3D printers behind me. I'm gonna be talking today about how do you do this 3D printing stuff? What is this all about? What is it that children, if you have them, are they out there learning? And then also, what is the potential for this for you? So for right now, I'm going to show you the Ender 3 and where you start. So I'm going to give it a minute just to see for other folks that are joining us. Right now we're printing a bunch of stuff, so what I'm going to show you first is we have 3D printers. Actually were started to print all different kinds of products and services. So this has a huge potential in major markets for all kinds of things. And that's what 3D printing was happening before COVID happened. But what you might be seeing in the public eye is a lot of things like this. Right now we have pivoted, instead of helping out the girls. Hi, if you're here, say hello, wave at us, comment so it can post up in the feeds and we can get some more folks watching. Ask questions if you have them during this. But we have pivoted into making face shields. So this is called PPE, or personal protective equipment, or PPE. So we've shifted into this. So what's awesome about this is that 3D printing can make a lot of solutions in real time. And so that's what I love about it. What we are planning on doing with girls when we can teach them again is get in front of them and use these 3D printers to teach construction components. So doorknobs, door handles, flower boxes, and eventually we'd like to do affordable homes. It's a little far out, but we're getting there. So we need to teach them early and teach them young. So that's part of our partnership with I Am Generation T. Generation T and Tracks of the Trades. And a lot of that, the future of trades, is tech. So where do I go from here? I'm going to do the basics really fast. This is called Fused Deposit Modeling, or FDM. You don't have to memorize this, but it's really basic stuff in the 3D world. What's the difference? It's hot ends, so there is actually a nozzle. There's a bed and a nozzle. And the nozzle heats up what's called PLA, or polylactic acid. Just test at the end, I promise. Polylactic acid, which is PLA polymer. It's basically plastic that's high temperature resistant and very sturdy. So there's a couple different kinds of this, but this is a huge spool of PLA. We use this. This gets about 26 face shields for us right now, so it's a lot of projects. And this is a big spool, so this is 1 kilogram. There are also smaller spools of this to make smaller projects. So the kids in school usually use primary colors. Right now we're using black. I want to show you some super cool colors because we are doing camps. We're doing virtual camps with Dottie Rose Foundation, who empowers tech-savvy girls in programming. They're helping us teach girls and boys, all gender non-specific, how to 3D print and how to design in Tinkercad. So here's some of the cool filament that we use for them to print right now. I'll show you a couple of the finished projects. They just finished up doing keychains and also some jewelry and pendants and things, so personalized objects. This is silky red, so this would make a pretty cool project. And this is gold rainbow, so this is kids are a big fan of the gold rainbow. These would make some pretty swag-tastic face shields though, so if you're in the medical community and you want a gold face shield, we can make that happen for you. There's also a lot of different brands, so this gets a little intimidating for folks. Hatchbox is one of my favorite brands. Overture is a second favorite, and Amelin Tech. All three of those are great brands for you. ABS, you'll always want to check, and I'm getting way ahead of myself because I want to go back to the printer, but ABS is a higher temperature, and this is my test on pronunciation. Acrylonitrile butadiene styrene. J-School grad here. So that's ABS, and that is like super high temp. It's tough and durable, and it's basically the highest level of dimensional accuracy because we're working on 3 planes here. So it's an X, a Y, and a Z coordinate, which makes it a little more math. So this is when you're getting into super sturdy, super high temp. We're making it work. We've had a lot of donations of ABS versus regular PLA. But if you're going and doing printing, say you want to get started with this and have a home printer for your family, that's what I want to walk you through. And you probably want to stay away from ABS and you just want to get straight PLA. So again, Hatchbox 3D, Overture, Amelin Tech. Amelin has glow in the dark, which is probably one of my favorite. But let's get back to this. So back to the printers. This is an Ender 3. We have a couple different types in our household right now. We have 4 printers running for the COVID-19 face shields PPE project here in Charlotte. These are the ones that I'm recommending for family use. So if you're out there and saying, hey, I want to invest in one of these, I want to get started, we're training a couple different companies, employees that are now having them delivered to their houses so that they can help in this effort for PPE here in Charlotte. And then after that, get into some fun family projects like what we have done with the kids. So we've done some virtual workshop labs, again, with Dottie Rose Foundation. This is, I'm not sure if you can see it. This is Victoria's yesterday. She did, this is in rainbow, and since this is dimensional, it's not thick enough for you to see more than a few dimensions. So this ended up being more purple than anything, but this could be rainbow if it was something bigger, like a vase. We also did, this is a keychain last week, so this was my daughter's. And what we found out here was we needed a back plate for that. So if you can see, she had a couple pop-out pieces that we knew in the second design, so version 2.0, that we would design with a back plate. A couple other, this is one of the girls' demos yesterday, a pendant. And this is our PLA, so you can see this. We're not going to put that around someone's neck. It's a little stiff, and I don't think that would be very comfortable, but it's good for just watching. So what do you need? Okay, an Ender 3. This is an Ender 3 basic. There's an Ender 3, there's an Ender 3 Pro. All of these are in the range of $200, $250. These are great for family use. It's not too much technology that's super intimidating. It's not too much of a whiz-bang printer that is just over what you would need in your household. It's still high output. Right now, to give you a good indication, these little projects take an hour or two, if not less. The face shields, which I'll show you, so I showed you our finished version of a face shield. This is our face shield that is getting donated to our medical community here in Charlotte and starting to be beyond. This takes about 5 hours. So, what do you start with? You start with an Ender 3. It comes in a box. We are going to skip the setup process because that does take, I would give yourself an afternoon. The Ender 3s, it's Creality, so C-R-E-A-L-I-T-Y, so creality.com, and they are overseas, but they're amazing. They ship very quickly. You can find these on Amazon. I know that they're a bit back ordered these days, along with most shipments. You know, they say priority, and it could be a month or so. We've had pretty good traction with this coming in even a week later. So your choice, but I would also go to the manufacturers because they have some discounts. They also discount their PLA quite a bit, so you can get a $10 off coupon. The PLA, a spool like this, that's just primary colors, black, white. This is around $20 to $23. And again, we get about 26 of our face shields. We've gotten our cost down to where our face shields are about $1.10 a piece. And we're in the midst of some talks with some production manufacturers to get it down to 85 cents a piece. And those are street market value of about $15 a piece regularly. So 3D printing really has a lot of immediate real-time solutions, but also cost advantages. So that's just the business part of me speaking. Back to this, what is 3D printing at its finest? It's 3 axes. So in your normal axes, you're printing flat. You're printing an X and a Y plane. So my mathematics nerds out there are going to get really excited about that. For our printing here, it's an X, a Y, and a Z axis. So you have to think of a third dimension and a third plane. Pretty Captain Obvious statement to make it a 3D object. So this is additive printing. There's 2 systems. There's a Cartesian and a Delta. That gets boring. I don't want to get into a lecture here. These are Cartesian printers. That means their bottom base plate actually moves. So it either moves forward and backwards or side to side to have that third dimension of the Z-axis print. Or there's a Delta, which is a circular plate and it's immobile. You might have seen that in manufacturers. They have these large Delta printers. These can be as big or little as possible. So not to say that Cartesian is just a family printer, but this is ones that you could make. Why I like these, your kids, if you have kids out there or grandkids, they work with mini cubes at their schools, so it looks like kind of something coming out of the Apple store. It's just a cube. So it gives you a little more limitations on what you can actually build and extrude high. That's why I like the open Cartesian printers, because we can make some pretty big things on this. We could actually go up almost 1.5 feet on this printer and make something pretty big, like a vase. Again, we're sticking with PPE right now, and then the fun projects with kids in our virtual workshops to get them exploring in Tinkercad. So with the Ender 3, that's your differences. That's just the basics. And again, it's a hot end. This is just polymer. So literally this PLA is polymer. Oh, I went off screen, sorry. This polymer, I lost this. All right, I'm gonna move over this way. A little bit. This right here, I don't want to touch it, but so it's polymer. We put the spool on top of the printer. The polymer loads in. I don't know if you can see this to the back. It loads into the back where there's a heating unit. The heating unit heats it up, so it basically just heats the PLA plastic, polymer, and it pushes through extraordinarily hot. I don't know what temperature that is. It pushes through down into the nozzle, and then it starts printing. So you can see our printer moving backwards and forwards, and I'm going to bring it up to you so you can see it. It really is the coolest thing ever. You can watch it, and that's printing a face shield right now. So it just goes back and forth, and this is making that Z-axis come to life. And all that is heated polymer that is pushing through, and there you have it. So I'm going to show you some details about this, because again, this is the fun stuff. So we like to make the fun stuff, like keychains. Again, we learned in Tinkercad that we wanted to put a base plate on here, and I see Sharon there. So Dr. Sharon helped us learn that in terms of making this something where it's flat on Tinkercad. So this is another thing. If you want to purchase an Ender 3, again, around $200 to $250 on the whole. Then you're going to have your spool, which is in the primary colors about $20. In these custom colors, so all of these fun colors that you saw, those fun colors are more like $25 to $35, just because they're glow in the dark or they're marble. It comes in just about anything you can imagine, and that's what the kids love. But if you get out there and you start looking at what people are producing in the 3D world, there's a lot of citizen printers out there, and they are the most creative people I've ever seen. So they're printing these huge, we want to do the Groot, there's a Groot planter from Guardians of the Galaxy. So we want to do this big Groot once this is all said and done. So we have all kinds of ideas for this once we're finished with our 3D printing of the face shields. So what I'm going to show you now is once you have this set up, so it takes about, I don't know, 4 hours or so. I think my husband Brian has gotten really good at this. I start throwing things, but it's not terribly difficult. You do have to follow some directions. The more expensive printers, when you get in the $1,000 range, $1,500 range, they auto level, and they are a little bit easier right out of the box to set up. These, I like them actually because it forces you to understand the technology. So the leveling, I'm going to get off of this one and again show you the printing. So it's really, one just finished. What happens at the end of a print is we use these just like the kitchen. This actually comes with a printer, so this did not come out of my kitchen. This is a scraper. So you literally scrape after it has cooled off, you scrape your final project off. So it really is kitchen-like, where you're just flicking it off and there's your finished project. So this was a, again, tester pendant that we used. But so that's, again, you can see that in motion. We're going to come over here and I'm just going to show you really quickly. If you do buy one of these printers, once it's assembled, and I'm going to do a little bit more detailed assembly video of that tomorrow for some folks that are getting it into their homes. So I'll post that as well. But once you have this in, and again, Ender is a great starter printer when you're outside of the mini range. I'm going to have you focus down on here. So all I'm doing is leveling. So if you can see the screen, I'm trying to see if you can see it. I don't think you can. I'm actually going to flip my screen because I'm going to see if that works. All right, This is way better. Okay, so I can show you this where I can flip my screen. This is what you would see on any of your basic printers. So right here, you have your nozzle. That's your nozzle temperature. So that is over here, what is heating up the printer. Then you have your bed temperature right here. So this is your bed right here. I don't touch it just because I don't want to unlevel. You can de-level this pretty easily. And then these are your axes. So right now we're not printing, so you see X, Y, and Z, what percentages, and what's off and what's on. Our fan is off right now. This is 100%. Our last project took us 3 hours and 45 minutes on average, and then it's 3:44:29. So it's telling you how smart of a speed you're going on. So this one over here that is actually printing, you can see we're 24 minutes in, it's printing. It's too initial stage to tell us like, hey, this is gonna be 5 hours for you, but it's pretty cool because as you get farther into that, it'll tell you, okay, you're 6% done, you've got another 2 hours to go, and you can get averages on what this printer can output out. So I think that they're almost like humans. It's kind of crazy. We haven't named ours yet, but they are family members, especially since they're on the bar top in our kitchen, because this was about the most level space we have. So first and foremost, you want to find a really level space. Right now I have used, again, we chose this because we knew this would be kind of a production factory here. It could be a really level dining room table. It could be a kitchen countertop, something that's got some weight to it and that you can also level out. Now to level these printers, for me, an Ender, this is an Ender Pro actually, so this is a little bit, all it is a slimmer power bank on this one, but it adds about $20 in price. So if I go here, I'm just going to our info screen, I'm going to prepare. You go to auto home. And so what's happening here is the printer is automatically leveling itself. It is getting itself back to base so that we can test it out. So then I disable my steppers, which is basically disabling the plate. And what we can do is test it out. So we're going to put a piece of paper under here and just check how we're doing on the leveling. And you can feel it right there if it's level or not. So with a piece of paper, we're making sure. And once we know it's level and you've got your range, sorry, I'm moving stuff around, plus I have a camera. Then it's really basic stuff. We go back, we hit print from TF. So basically that would be from Tinkercad. You get what's called an STL file. And that STL file gets converted to a G-code. So it's kind of like taking a Word document and putting it into a PDF. So it's final. And the printer can read the X, the Y, and the Z axes easily. So G-code is the language that is used here. So after you've made your super cool keychain here, or your super cool this was Victoria's project, oops, backwards, Victoria's ring yesterday, then she would send that STL file, it's a .stl, and that software comes with an Ender 3 or a basic printer. It's a slicer basically, so it's going to convert for you. So you just download that as part of your file so that you can take this, STL turns into G-code, and then you put in your USB on the side and get ready to print. So it's pretty simple stuff. In terms of leveling, sorry, I forgot too. Underneath is where you level both sides. So this is not an auto leveler. This is one where we have to level it ourselves. So again, this is an STL file that's converted to G-code. Then we can send it to the printer via a USB, which is right on the side, and we start printing. So for us, we already have print from TF. And you can see right now, we've had a few things. We've had Dottie Rose keychain, so we printed that. 2 covers, that's another home project, and then a 3-hole shield. That's what we want to print. And it will start itself, and right there you see bed heating. So it takes a minute to heat, and then it starts up. So this is super, super duper simple stuff. Love it. I can't say enough about it. I can't wait to get started on a lot of the other projects after we do and finish the need. This need could be for a while for our face shields. Again, this is what we print, and then there's a middle piece here too. Let me go into my production factory of our dining room, which will give you the final. So there's also a middle piece there. And the cool thing is, for something like this, that final sheet, that equals what is basically our kit here. So what we have are film, so this is protective film that actually still has the plastic on it. So once the medical provider gets this, they can rip that off themselves, so it stays protected until they need to use it. We've got our shield piece. This is a Prusa design. So Dr. Joseph Prusa has come up with some universal designs. You can see they have their logo on the side. Universal designs that have addressed the need for face shields, some N95 prototypes they've done. Now they're doing ear guards, so the things that are kind of ear savers on the back for face masks. There's all kinds of things coming out of Prusa's workshop, as well as some other, again, citizen printers. The cool thing is we can easily transfer those, and we just got the latest yesterday, or excuse me, this morning, where there's actually one like this that has a nose guard on it. So it's got a little piece that comes out of the top and actually protects the provider's nose once they put that on and have the shield film over top. So it's amazing to see the value engineering that's going on and how fast that's at work and how fast we can implement it. So that's really the potential of 3D in the future. It's amazing stuff. And this is absolutely for home use. So my goal and my dream here at She Built the City is we would